Step 4, exploring data. We've already read in the dataset into R. We've completed the data cleaning step, the descriptive analysis, and the pre-processing. And what we finally want to do is we want to look at the multivariate structure, and we want to look at the dependency structure between numeric variables using principal components analysis. We'll use the vacation motive dataset. Here the backmod matrix, which contains the agreement with the vacation motifs as 0 and 1s as input. The function procomp in our performs principal component analysis. And principal component analysis looks at the dependency structure between these numerical variables, and we can use either the covariance or the correlation for this. And by default the covariance is used because the vacation motifs are all collected on a binary scale, which is comparable. There's no need to use the correlation here. So we execute this. And what function procomp does, it returns an object of class procomp, and we can use the default print method to have a look what's contained in this object. And here we get sort of a rather lengthy output, which first shows us the standard deviations of the principal components. We see this is a decreasing sequence. So this is the standard deviation of the first principal component. This is the standard deviation of the last principal component. And what we get in addition is the rotation matrix. So how does the original data, the original variables need to be rotated to get the observations in the principal component space. So these rotations, if you look here, how is the data rotated to obtain the first principal component, we see all are negative, which means that this principal component only allows us sort of to distinguish between all motifs apply and none of the motifs apply. Whereas for the second principal component, we see we have high absolute values for luxury and be spoiled. For entertainment facilities, and here a negative value for maintaining an unspoiled surrounding. So these are the variables which sort of characterize the second principal components. We can look at the rotation matrix to get an insight into what the principal components are composed of, what they represent, but we'll see this might be easier to see using a visualization method. What we also want to look at is what does the summary method returns for procomp objects. And here we see this again contains the standard deviations, so the same sequence of 20 numbers we've already seen, and also in what is this in proportion of total variance contained in the dataset. So the first principal component explains 18% of the total variance in our dataset. So on average, like if we have 20 variables, each variable should about explain 5% of the variation. And here we have the cumulative proportion, because often people are interested in how many principal components are, for example, necessary to contain at least 80% of the original variance contained in the data. Here this would mean we would need to use 13 principal components to retain at least 80% of the variance. So this means we see that the travel vacation motive data cannot be really represented by easily using lower dimensional representation of only 2 or 3 principal components. So now we look at a visualization which might help us to interpret each of the principal components. So we do this using a function from package FlexClust. So we load this package and then we plot the predicted values. So predict on the procomp will give us the coordinates and the principal component space for our original observations, and because we said the first principal component is not really of interest, we'll use the second and the third principal component, and we'll plot now this original data in that new space using dots, filled dots in grayscale. So this is how the projected data into the second and the third principal component look like. And what we now add is the projection axis, which contains the information of the rotation matrix, which will allow us to identify which variables are important to characterize two principal components. So we add this, we zoom in to see better, and here, as we have already seen when looking at the rotation matrix for principal component 2, it's important that this fun and entertainment, luxury be spoiled, so these are variables with a high loading, but also maintain unspoiled surroundings, but they go in different directions. So people either agree that fun and entertainment and luxury being spoiled is a travel motive for them, or maintaining unspoiled surroundings is a travel motive for them, but they don't do this at the same time. Whereas for principal component 3, we see not exceeding planned budget is an important aspect, and as a reverse, those people who don't care about their budget, they are, say, as a travel motive, cultural offers and the lifestyle of the locals is important to them.